On a quiet night in early September 2025, while the world slept and the sky over Europe shimmered with its usual constellations, a lone observer leaned over an aging laptop in a small apartment in Ukraine. His name was Vladimir Bezugi, an amateur astronomer whose tools were nothing more than an old computer, a set of custom scripts, and a decade-old passion that refused to die. He scrolled through fresh hydrogen emission difference images from Soho, expecting nothing more than the usual noise and faint variations. But then, somewhere between two ordinary frames, a smear of blue-green brightness pulsed into view. Subtle at first, almost shy, then stronger and clearer with every passing image. It didn't behave like a star. It didn't behave like an artifact. Instead, it seemed to grow between frames, a plume of gas expanding with unnatural speed. Vladimir froze. His fingers hovered above the keyboard. In more than 20 Comet discoveries, he had never seen anything ignite across a sensor like this. He reran his scripts, isolated the anomaly, filtered the noise, then circled the blooming source in red. It wasn't a glitch. It was real. Within minutes he pushed the images to the Comet ML mailing list, then to a Telegram group dedicated to monitoring spaceborne hydrogen emissions. At 1:30 in the morning UTC, he sent a formal report to the Minor Planet Center. The magnitude was 7. Bright enough for binoculars. Bright enough to shock the professional world once morning arrived. By sunrise, telescopes across the Czech Republic, Chile, South Africa, and Japan pivoted and locked onto the newcomer. The Fram telescope confirmed it first, a massive coma larger than entire planetary disks, trailing a tail that stretched wider than 5 moons. Soon the world had a name for it, Comet Swan, an object 400 times brighter than the interstellar Wanderer 3I, Atlas, and hundreds of times broader in the night sky. It was visible to anyone who bothered to look up. But the real story wasn't its brightness. It was how it had been found. Not by billion-dollar surveys. Not by automated detection systems. But by a single dedicated watcher in a modest Ukrainian apartment. Vladimir had outrun the machines. Professionals scrambled to understand how something this large and this radiant slipped past their instruments. They blamed hydrogen line sensitivity gaps, survey downtime, blind spots near the celestial equator. But none of it erased the deeper question: if a comet so bright had escaped attention, what else might be roaming just out of reach? Within the first 12 hours, mathematicians and orbital specialists began plotting Swan's trajectory, and their results sent ripples of unease through observatories around the globe. The comet would swing dangerously close to the Sun, barely half an astronomical unit away, roughly the distance between Earth and Venus. Then, just 5 weeks later, it would skim past Earth at only 39 million kilometers. That's inside Mercury's orbit, close enough that the tail could stretch across entire constellations in the night sky. Swan was venting energy at a rate that defied expectations. Fresh ices were erupting under sunlight, blasting gas and dust into space with a power output measured at nearly 10,000 gigawatts. It was like watching a floating power station run unchecked, its breath brighter than the combined glow of Earth's cities. Even seasoned comet experts admitted they had never seen something so active so early. Its movement was fast enough to be noticeable from night to night. Amateur astronomers tracked its shifting position with nothing more than backyard mounts. Professionals scrambled to capture high-resolution spectra before the comet changed again or disintegrated under its own violent outbursts. Every hour mattered. Naturally, comparisons to the interstellar object 3I, Atlas, were unavoidable. Atlas was smaller, dimmer, and far harder to observe, its magnitude buried around 13 hundreds of times fainter than Swan. But Atlas carried its own intrigue. It wasn't born in our solar system. It came hurtling from the depths of interstellar space at 58 kilometers per second, faster than any natural object observed that year. Its hyperbolic orbit guaranteed a one-time visit, a brief brush past the Sun, and then an eternal departure into the void between stars. While Swan dazzled the public, Atlas captivated the scientific community. When the European Southern Observatory turned the very large telescope toward it, the spectral readings raised eyebrows instantly. The coma was dominated by carbon dioxide in quantities rarely seen, an 8-to-1 ratio over water vapor. Even stranger, nickel vapor showed up in abundance, something comet researchers almost never detect. Atlas was a chemical outsider, a fragment of a world that formed around an entirely different sun. For a few days, the sky played host to two cosmic messengers. One bright enough for anyone to see, the other holding alien chemistry locked within its faint glow. But then the universe threw a complication into the story. In early October, both comets slid behind the Sun, dropping below the safe observation angle. Telescopes could no longer track them without risking permanent damage. A blackout began. 11 days of silence, right when Swan neared Earth and Atlas neared perihelion. The moment of greatest activity, greatest change, and greatest danger vanished behind the Sun's blinding light. And all scientists could do. When the blackout began on October 8, the astronomy world entered a kind of collective paralysis. Observatories that normally streamed data every minute suddenly had nothing to offer. Instruments from orbiting satellites to ground-based giants went blind. Even amateur watchers, usually the last line of detection, could only stare helplessly toward the horizon. Swan and Atlas were out of reach. For 11 long days, simulations replaced observations. Teams ran thousands of orbital clones, individual trajectories slightly tweaked to account for unknown jets, mass loss, or brightness variations. Each simulation whispered a different outcome. Some showed Swan emerging brighter than before. Others suggested it might split apart during perihelion. A few hinted at complete dissolution. Thousands of possibilities. No real answers. Even the orbital period of Swan became a battleground. Analysts at the Minor Planet Center, working with the most precise early measurements, pinned its period around 1400 years. A comet likely observed during ancient empires and destined to return again within recorded history. Meanwhile, NASA's Jet Propulsion Laboratory, relying on slightly earlier and noisier pre-discovery images, calculated a period closer to 20,000 years. A staggering mismatch. Not a dispute born of ego, but the result of incomplete data and the unpredictable physics of volatile jets pushing on the nucleus. Both sides defended their models. Both admitted they might be wrong. Science had hit its limit. And while the blackout dragged on, the rest of the sky continued its quiet dance. Amateur astronomers uploaded older images they had forgotten to process. Professionals dug into archives looking for faint pre-discovery hints. Global forums turned into digital command centers, where data, predictions, and anxieties spilled into endless threads. Everyone understood they might be missing the comet's most dramatic moment, its transformation, its fragmentation, or its brightest peak, hidden by the Sun. But then something unexpected happened. While Swan and Atlas disappeared behind the solar glare, a third object began stealing the spotlight. A newcomer, Comet Lemon. It brightened faster than predictions, soon reaching magnitude 4, bright enough to cut through moderate city glow. Its tail stretched gently across a tapestry of stars, announcing that the comet season wasn't finished yet. For a brief, surreal moment, three comets, one blinding, one interstellar, and one freshly awakened, shared the same era of the sky. It was a cosmic trifecta the world had never seen in modern times. Still, Swan remained the emotional center of the story. When it finally re-emerged from behind the sun, faint and ragged, astronomers gasped. It had survived, but it was not the same. Its once immense 2 to 5 degree tail had thinned, its brightness reduced. The comet that had once glowed at magnitude 6.2 had dimmed noticeably. Swan was alive, but quieter, as if exhausted from its furious encounter with solar radiation. Atlas, on the other hand, emerged weaker than ever. Its nucleus appeared fractured. Its brightness refused to rise. The interstellar wanderer was fading into a ghost, destined to vanish into deep space once it cleared the planetary region. What remained was mostly data, spectra, tail measurements, dust profiles, a record of alien chemistry carried by something likely far older than Earth itself. As days passed, astronomers continued to refine trajectories, brightness curves, and mass loss rates. But the fundamental uncertainties never fully resolved. The exact orbital period of Swan remains one of the most debated parameters of any bright comet in modern times. The difference between 1400 years and 20 millennia became a symbol of the limits of human knowledge, of how even in an age of automated surveys, supercomputers, and billion-dollar telescopes, the cosmos could still keep its deepest secrets hidden behind a few days of sunlight. Yet the story's heart belonged to Vladimir Bouzougi, a man with a battered laptop and an unbreakable habit of checking Soho hydrogen maps long after midnight. His discovery proved that astronomy is not a closed field owned by institutions. It is a living collaboration between professionals and citizens. Swan became a monument to that truth. In the end, the season of 2025 was unlike anything in recent memory. A sky lit by multiple comets. A showdown between brightness and mystery. Swan glowing 400 times brighter than Atlas. Atlas carrying chemistry no one expected. Lemon arriving as if on cue. 11 days of global blindness. And a disagreement spanning 19,000 years over the path of a single icy traveler. These comets didn't just streak across the sky. They reminded humanity that even in the age of high-tech surveillance, the heavens can still surprise us. They can still hide their wonders.